So in this particular problem, we need to determine the derivative of this function sine inverse of x over square root of x squared over a squared with respect to x. Well, we can do an u and a v substitution here, but the goal will be to save some computation time. So let's straight away jump into the problem. So here we have to take the derivative of the inverse sine function. So let's first note down the formula. So we have derivative of sine inverse of x with respect to x. So that's given by 1 over square root of 1 minus x squared. Now what we'll do, we will assume that this x over square root of x squared plus a squared, so this is behaving as x. Then in that situation, we have 1 over square root of 1 minus, according to the formula, we have x squared, but we will assume that x is x over square root of x squared plus a squared. And then we square it. However, since this is an assumption, so what we have to do, we have to apply the chain rule. That means we need to multiply it to the derivative of our assumption. So our assumed value expression was x divided by x squared plus a squared. So this is how we can apply the chain rule. That will be equals to 1 divided by the square root of 1 minus x squared divided by x squared plus a squared times. Now here we have to find out the derivative by using the quotient rule. So let's begin. So we begin with the denominator. So we have x squared, square root of x squared plus a squared. So we write it in the denominator and then square it. Then we start again with the same expression. We have square root of x squared plus a squared. We don't do anything to it. Then simply multiply it to the derivative of the numerator, which is x in our case. Minus, now we have already taken the derivative of the numerator, so now I will take x and then multiply it to the derivative of the denominator. So that's square root of x squared plus a squared. So this will be 1 over square root of, so we have a common multiple in the denominator, which is x squared plus a squared. And in the numerator, we have x squared plus a squared minus x squared. Multiplied to, let's compute the numerator. So here we have square root of x squared plus a squared times derivative of x with respect to x. So that's simply 1 minus x times. Now what's the derivative of square root of x squared plus a squared? So I'm going to skip the steps here and straight away write the answer. So I'll leave it as an exercise to you. All you have to do is apply the power rule. What you have to do is ddx of x squared over a squared. The square root can be written as x squared plus a squared whole raised to the power of half. Go ahead and try it out. So its result is going to be x divided by square root of x squared plus a squared. Whole thing is divided by square root of x squared plus a squared whole squared. So that's simply x squared plus a squared. So we have this x squared and x squared terms cancelling with each other. So this will be square root of x squared plus a squared, whole thing divided by square root of a squared. So we will get only a here in the denominator. Fine. Then let's multiply this x with this particular x. So this will become x squared. Let me cancel this out. So this is x squared, and we'll combine the two expressions in the numerator. So that will be x squared plus a squared. So we have multiplied root over x squared plus a squared with square root of x squared plus a squared. So the square root goes away. Minus x squared whole divided by square root of x squared plus a squared. Then we have x squared plus a squared in the denominator. Here, this square root of x squared plus a squared and this one goes away immediately. And we have this x squared and this x squared going away. And then we have a squared over a. So 1a from the denominator and 1a from the numerator goes away, leaving us with only a term a in the numerator. So that means our final expression, the simplified expression, will be equals to a divided by x squared plus a squared. So this is the derivative of our given function. So this is a divided by x squared plus a squared, which turned out to be very simple compared to the original function.